Good morning, students. HS second year mathematics. Now it is chapter 1, that is relation function we are going to do. Today it is fourth lecture. Now let's start the class. So today we have done up to question number 8. Up to this one we have done. Now we will do question number 9. Question number 9 is like that. First part I have given as homework, that I will not show today. Second one, if I show, it is similar to that one. So let's start second part. Show that the relation R in set A, x equal to x belongs to Z, x greater than equal to 0, less than equal to 12, and R is given AB, A equal to B, R equivalence relation that we have to prove. Find the set of all elements related to I in related to 1 in each case. So now we are going to do question number 9. A is what? X belongs to Z means integer. It is given, and R is equal to AB such that A equal to B. Now we have to show first that it is equivalence relation. So this one, actually if we want to write, so it is greater than equal to 0, less than 1, 0, 1, 2, like that up to 12. This is actually A. A is what? X belongs to Z as it is integer from 0 to 12. So actually this want to mean 0, 1, 2, dot, 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 12. This one is what? AB if A equal to B. That means 0, 0, 1, 1, 2, 2. This way all the elements will be like that. So this way we have written here 0, 0, 1, 1, 12, 12 belongs to R, implies R is reflexive. Now 0, 0, its reverse, 0, 0 belongs to R, then its reverse is also there. Its reverse is again 0, 0. In this way, we found every elements. It's if we change, it is same. So R is symmetric also. And another thing, if AB BC belongs to R, then AC belongs to R, then R is what? Transitive. So here, as we cannot make like this one, so we can say R is transitive. So as R is reflexive, symmetric, transitive, then R is equivalence relation. R is what? Equivalence relation. So that is the thing, that R is what? Equivalence relation. Now, next part they said what? That find the set of all elements related to 1. Here, related to 1, which one is there? Only 1 is there. So, required set, or it is this way we can write, that is equivalence class of this one. It is what? Set containing element 1. So, this is your answer. So answer is what? That that how many elements are related to 1? Only this one is related with 1. Okay, now we will do our next sum. Our next sum, they said that given example of relation, give one example of relation where which is symmetric but neither reflexive nor transitive, transitive but neither reflexive nor symmetric, reflexive and symmetric but not transitive. Then fourth, reflexive and transitive but not symmetric, symmetric and transitive but not reflexive. Now see how I can write. See, if set is 5, 6, 7, R is what? Relation is 5, 6, 6, 5. Then R can be called as what? Only symmetric. Only symmetric we can say. And it is neither reflexive nor transitive. If I write this one, then R becomes what? Transitive but neither reflexive nor symmetric. 1, 2, 2, 3. 2 to hide, then it becomes 1, 3. Reflexive not there because 1, 1, 2, 2, 3, 3 not there. Symmetric also not there. 1, 2, 2, 1 not there. Here you see that it is reflexive and symmetric but not transitive. Reflexive because 1, 1, 2, 2, 3, 3 there. 1, 3, 3, 2. So there should be 1, 2 for being transitive, but 1, 2 is not there. But 1, 3, its reverse 3, 1 is there. 3, 2, its reverse 2, 3 is there. So it is transitive but not symmetric. Reflexive and transitive but not reflexive and transitive but not symmetric. So this one is like that. 4 is what? So 3 is finished, 4 finished, and last 5. This is not transitive. And last one is 1, 2, 3. So last one is what? Symmetric and transitive but not reflexive. Not reflexive because 1, 1, 2, 2, 3, 3 not there. Transitive because 1, 2, 2, 1 is there. If you hide, 1, 1 is there. Symmetric because 1, 2, reverse 2, 1 is there. So this is your answer of question number 10. Now we will do question number 11. Now question number 11 we are going to read, and it is what? The question is, show that the relation R in the set A of points in a plane given by R is equal to PQ. Distance of point P from origin is same as the distance of point Q from the origin is an equivalence relation. This we have to prove. So let's write the question. Answer is what? R is equal to PQ. And they said what? Distance, it is possible only when distance from origin to, that is OP is equal to OQ. O is origin. I have written little different way. Origin. Now we have to prove it is equivalence relation. How we can prove it is equivalence relation? For any P belongs to, our set is what? A. If we take a point A, then OP is equal to OP. We can write. If I take a point, suppose this is a coordinate system, if A take point P, this distance same, implies what? OP is equal to OQ, then PQ in the R. So here OP is equal to OP, PP belongs to R. Implies R is reflexive. So R is reflexive. PQ, if it belongs to R, implies OP is equal to OQ. We can say OP is equal to OQ. Implies OQ is equal to OP. Implies Q comma P belongs to R. Definitely, OP is equal to OQ and OQ is equal to OP is same thing. PQ belongs to R, we can write like that. Implies R is symmetric. So R is symmetric. Suppose PQ comma QR. 2 R can create problem. So PQ QS I belongs to R, implies OP is equal to OQ, and for this one OQ is equal to OS. So OP is equal to OQ and OQ is equal to OS. So we can write OP is equal to OS. So implies PS belongs to R. R is transitive. So of course R is what? Equivalence. Therefore R is equivalence relation. So this way we can prove that how it is equivalence relation. So it is easy way of writing this way. Then they say second part, that show that all the points related to the point P not equal to 0, 0 is circle passing through the P with the origin as center. So suppose related with P, if PQ belongs to R, implies OP is equal to OQ. If PS belongs to R, is OP is equal to OS, and so on. So on, which states Q dot S dot lies in circle, because in circle only lies in circle. It lies in circle. Why? Because we know in a circle is what center. If we draw suppose a circle, then all the points here, this from circumference. Distance from origin, it is the radius, it is same. Here you see that OQ, OS, all are same. So PQS dot dot dot, so many points if we find, all will lie on the circle having center O and radius is of course OP. Now we do our next sum. Now question number 12. Question number 12 is like that. Show that the relation R defined in the set of A all triangles as R is what? T1, T2 such that T1 is similar to T2 is equivalence relation that we are going to show. Question number 12. Here R is given as T1, T2. T1 is similar to T2. This is similar symbol I have written. We have to show this is what? An equivalence relation. So equivalence relation it is, we are going to show, and T1 for any T1 belongs to A, T1 is similar with 1. One triangle is similar with itself. Therefore T1, T1 belongs to R implies R is reflexive. T1, T2 belongs to R implies T1 is similar with T2. T1 is similar with T2 implies T2 it is similar with T1 implies T2, T1 belongs to R implies R is symmetric. So symmetric it is. T1, T2, T2, T3 belongs to R implies what? T1 similar to T2, T2 similar with T3. One triangle similar with one. This one similar with this. So easily we can say T1 is similar with T3 implies T1, T3 belongs to R implies R is transitive. So R is reflexive, symmetric, transitive. Therefore R is equivalence relation. So we have proved this is equivalence relation. Next part they said consider three triangles, three right angle triangle with side 3, 4, 5, T2 with side 5, 12, 13, T3, 6, 8. Which triangle among these are related? Two triangles are similar if they satisfy the condition if all corresponding angles are equal, A, or ratio of corresponding sides if they are equal, ratio of corresponding sides. So here you see that 3/6 is equal to 4/8. 3/6 is half, 4/8 is half, and 5/10 all are equal to what? Half. So these 3, 4, 5, these are the sides of what? T1, and 6, 8, 10, these are the sides of what? T3. So of course T1 and T3 belongs to R. Therefore T1, T3 belongs to R. T1 is related with R only. So now next question, question number 13. 13 is what? Show that the relation R defined in the set A of all polygons given as R equal to P1, P2. P1 and P2 have the same number of sides is an equivalence relation. So this we are going to prove that if the number of sides are same, they should belong in the. So 13. So now it is what you can R is equal to P1, P2. P1, P2 have same number of sides. Now, for any P1 belongs to A, so P1 and P1 have the same number of sides. So P1, P1 both you can take because they have the same number of sides. So R is what? Reflexive. P1, P2. If we take within R, then P1, P2 have the same number of sides. We can reverse this one. P2 and P1 have the same number of sides. So we can write P2, P1 within R as both have the same number of sides, implies R is what? Symmetric. P1, P2, P2, P3. See here, P1, P2 has the same number of sides, P2, P3 has the same number of sides. So can we say P1 and P3 has the same number of sides? Of course, that means P1, P3 belongs to R only. Implies R is what here? Transitive. Therefore, R is equivalence relation. So this way we can prove these things. Now next part they say, what is the set of elements in A related to the right angle triangle with the sides 3, 4, 5? If side says 3, 4, 5, so 3 sides, so here we can say that all the triangles, because 3, 4, 5 is what? Second part I am telling. Second part, they said what? That if the triangle has side 3, 4, 5, here the side measure is not required. It is 3 side given means triangle. So one triangle is related with what? With another triangle only, because they will exist if both have the same number of sides. একটা যদি পলিগনের এখানে যতটা সাইড এখানে যতটা সাইড, দুইটা যদি নাম্বার অফ সাইড সেম থাকে তাহলে এটা আর এর মধ্যে থাকবে। তো এখানে কি না, সাইডের মেজার দরকার নেই, তিনটা সাইড এটাই বলছে 3, 4, 5 সাইড আছে। সো হোয়াট উইল বি দ্য আনসার? that here you will write that set of elements related to T is set of all triangles. So this is the triangles. So this is the answer of question number 13. Now question number 14. 14 is what? That let L be the side of all lines in xy plane and R be the relation in L defined as R equal to L1 L2. L1 is parallel to L2, so that R is equivalence relation. Now we are going to prove this one. So it is question number 14. It is L1, L2. L1 is parallel to L2. We have to show this is what? Equivalence relation. So we have to show this one is equivalence relation. Now for any L in xy plane, so L is for any L is parallel to L. One line is parallel to itself. Implies L, L belongs to R. Implies R is reflexive. Now L1, L2 belongs to R. Implies L1 parallel L2. We can say L2 also parallel to L1. Implies L2, L1 belongs to R. Implies R is symmetric. Now L1, L2, L2, L3 belongs to R. Implies L1 parallel to L2, L2 parallel to L3. Implies L1 is parallel to L3. Implies L1, L3 belongs to R. Implies R is transitive. Therefore, R is equivalence. So this we have to. Now second part it is say find all the lines related to this one. So of course we can say they say if it is y equal to twice x plus 4, then it is an equation of straight line. Then set of all lines which is related with this one. That means all the lines which are parallel to this one we have to find. So two lines are parallel if m1 is equal to m2. Gradient or slope, if they are equal, then two lines are parallel. So required set will be what? If we write that y is equal to twice x plus c, instead of 4, that is, we have written an arbitrary constant c, that is slope is same, then this can be called as what? Our arbitrary solution. So we have written this one. This is what? Arbitrary number here, y-intercept. So this will give what? Total number of lines which are parallel to this one. Now question number 16, it is question number 16 and 17 I don't want to show because it is 15 and 16 I am to give as homework, and then we will go jump into our next exercise, that is functions, and it is 1 2 function that I want to do. So function little bit we will explain today. Let A and B two empty sets. A relation f from A to B which associates with each element of X belongs to a unique element. So it function already defined in class 11, that is a set if a what relation from set A to B is called a what function if every element of set A has a unique image in set B. Then here you have to find 1 function and 1 function. 1 is what? That 1 image if it is found, then it is 1 function. If we get more than that is all elements, let's draw the figure and I will explain. So function chapter we are going to start. Function it is 1 first. 1 function. Suppose here how to do if fx1 is equal to fx2, and ultimately by calculation if you can able to find x1 is equal to x2, then it is 1 function. Suppose here it is set A 1 2 3 4 A B C D E. Suppose 1 is connected with A 2 C 3 B 4 D. Here you see that two elements are not merged in a single element, so it is what 1 1. So it is 1 1, and onto is what? Onto function. Suppose if there is no extra element here, suppose 1 2 3 and here AB, 1 is connected with B, 2 is also 3, it is not 1 1 because 1 and 2 both are connected with A, but there are no extra elements, so it is 1 2. How to do? For any y belongs to B, if there exist x belongs to A such that fx equal to y, then it is 1 2. It is just definition. When we will do the sum, then it will be more clear. So it is this way we will start our next exercise in next class. So I expect all of you have learned. It is just one, that if fx1 is equal to fx